We want to find the Taylor expansion of function. Our function here is sine x divided by cosine x plus 2. Around the origin, going up to x to the power 3. So what does that mean? A Taylor series is known as f of x is equal to sigma as n is equal to 0 up to infinity, f of a n divided by m factorial times x minus a to the power n. And when we say around a certain point, that means a is equal to 0 here because we're finding the Taylor series around the origin. And we only care about the powers up to x to the power 3. So when we have a equal to 0, that gives us a Maclaurin series. And it looks like this. F of x is equal to, it will be f of 0 plus the first derivative of the function at a is equal to 0 x plus the second derivative at 0 x squared divided by 2 factorial plus the third derivative at 0 x cubed divided by 3 factorial, and it goes on. So looking back to our function, let me write it here one more time. Sine x divided by cosine x plus 2. It's clear here that we need the first derivative, the second derivative, and the third derivative. So let's get the first derivative here. We have a quotient, then the derivative is the denominator would be the denominator squared. And the numerator of the derivative is going to be the derivative of the numerator, which is cosine x, times the denominator, which is cosine x plus 2, minus the derivative of the denominator, which is sine x, times the numerator, which is sine x. All right, this is the first derivative. Now let's get the second derivative. Of course, I'm kidding. We will not do that because it's a huge function, and this is not how these problems are solved. What we actually do is use the Taylor series of famous functions, which we already have. Our function is sine x divided by cosine x plus 2. We will actually use the Taylor series of sine x and cosine x. So the Taylor series of sine x is x minus x cubed divided by 3 factorial plus x to the power 5 divided by 5 factorial, and it goes on. That would actually simplify to x minus x to the power 3 divided by 6 plus x to the power 5 divided by 120, and we don't care about the higher powers. What about the cosine x? Well, it's equal to 1 plus x to the power 2 factorial divided by 2 factorial plus x to the power 4 divided by 4 factorial, and goes on. That simplifies to 1 plus x squared divided by 2 plus x to the power 4 divided by 24. And we don't care about the rest or higher powers. All right, then we're going to substitute that in our function. So let me change the color here. It's going to be, in place of the sine x, we're going to put x minus x to the power 3 divided by 6 plus x to the power 5 divided by 120. And for the denominator, we have, in place of the cosine x, 1 plus x squared divided by 2 plus x to the power 4 divided by 24, and plus 2. We had a plus 2, cosine x plus 2. So now, from the denominator, I actually care about this one. So I'm gonna gather here, sum the constants, 1 plus 2, and take it outside as a common factor from the denominator. So it's gonna look like this. 1 over 3 as a common factor, then the denominator would be 1 plus x squared. Now I divide by 3, so it's going to be 6 plus x to the power 4. I divide by 3, so it's going to be 72. And up we still have x minus x to the power 3 divided by 6 plus x to the power 5 divided by 120. Then I'm going to write it that way. 1 over 3, 1/3, times 1 over 1 plus x squared divided by 6 plus x to the power 4 divided by 72 times the numerator, which is x minus x to the power 3 divided by 6 plus x to the power 5 divided by 120. So why I wrote it that way? Because I care about simplifying that denominator. So I wrote it in that fashion to use the generalized binomial theorem, that it says if we have 1 over 1 plus u, that is equal to 1 minus u plus u squared, and it goes on. So if we say that u is equal to x squared divided by 6 plus x to the power 4 divided by 72, then we can say 1 over 1 plus x squared divided by 6 plus x4, x to the power 4 divided by 72 simplified is equal to 1 minus u, which is 1 minus x squared divided by 6 minus x to the power 4 divided by 72. So right now, in place of the denominator, I have another uh, term here to multiply by the numerator that I had. So then our function reduced to 1/3 times, now the 1 over the denominator now is 1 minus x to the power 2 divided by 6 minus x to the power 4 divided by 72 times the numerator, which was x minus x to the power 3 divided by 6, and it goes on. So now what we need to do is do the multiplication. And see, I only care about the powers that are up to x to the power 3. So if I take this term here and multiply by the 1, then I'm going to have x. And take x here, also multiply by this term. So it's going to be negative x to the power 3 divided by 6. But if I take the x and multiply by this term here, I'm going to have a power that is higher than x to the power 3. So I'm going to ignore that term. And then I'm going to jump to this term here. Multiply by 1 here. That is going to give me negative x to the power 3 divided by 6. And there are no other available multiplication because they are going to give me a power that is higher, x power higher than 3. Then these are the terms that I'm going to keep and the others I'm going to ignore. So it's 1/3 times x minus 2x cubed divided by 6. That is going to simplify to 1 over 3, oh, I'm sorry, x over 3 minus x to the power 3 divided by 9. And here is the a Taylor series of the function that looked a little bit complicated, by using the series of famous functions would actually help solving the problem.